Hello, welcome. In this video, we're looking at the dilation of a point by some negative scale factor, and we want to state the coordinates of the image if the center is either at the origin or some other point. So the origin is pretty nice. If you're at the origin, you take the scale factor, so whatever it is, in your original point xy, and you just multiply k by both x and y, and that will give you the image you're looking for. So in our case, we're going to take -3 times -7/2. That's going to get you positive 21 over 2. And then 2 times -7/2 is going to get you negative 14 over 2. And 21 over 2 is 10.5. And negative 14 over 2 is -7. So it's going to get me 10.5 or -7. And then we're done. But for a dilation about a point that's not the origin, it's a little bit more involved. There's a couple of ways to approach it. I'll try to show you some of the things I do. We'll look at it graphically first. So let's maybe pay attention to this. Our point is -3, 2, and we're going about the point 1, 4. So let me try to remember that. So type in that point. -3, 2, I think it was. Yep. And Q, sorry, is 1, 4. Okay. So here is the point Q, here's the point P. And our scale factor, I'll say K equals -7 over 2. And you can turn this into a slider so you can change it. Can I not turn it into a slider? So here, let me just delete this. I'll say K. If I just type K equals 1, and now I can change it, -3.5, right? It gives me a value on the slider. Okay, so let's look at what's happening here to make sense of it. So we want to dilate some object by some dilation factor about some center. So the object we're dilating is P, the factor is K, and the center is Q. Okay, so here, it actually gives us P prime right away. There it is, sorry. So first of all, what did our instinct tell us? I scrolled down here. I shouldn't have. Think about what's going on. This is the center. A positive dilation would say whatever distance this is, keep going in that direction. So if the scale factor was 3.5 positive, whatever this distance is, I would make it 3.5 times longer in this direction. But it's negative, so it should go on the other side of Q. So my instinct should have been to scroll up here. And you can kind of estimate that whatever this distance is from Q to P, you can see that it does seem reasonable. The distance from Q to P prime is it's longer. It's about 3.5 times longer. All right, so how can we compute this? What are some common ways to deal with it? So one way to deal with it is to find the slope between these 2 points, compute it, and then use that to find the image. So I'll show that one first. Take a little screenshot. Go back here. I think I'll use a new page. Wow, that's a lot bigger of an image than I need. So we'll reduce that in size. So this algorithm's cool because it uses slope and movement on a graph, right? So it would say here Q, which is 1, 4, and P, which is -3, 2. It would say, what's the slope between these 2 points? Well, I'm going left and right from 1 to -3, but I'll actually go in this direction from P to Q. So I'm going from -3 to 4. That is an x increase of 4, and our y is going up by 2. So the distance from P to Q takes us on a slope of up 2 and over 4. So we want to go 3.5 times in the negative direction to the opposite side of Q to get to its image. So instead of going up 2, we go up by 2 times 3.5. It's 3.5. And we don't need the negative here because we're already accounting for that by going on this side of Q. If it was positive, we would be counting in this direction down here. So 2 times 3.5 is going to be 2 times 3, which is 6, plus a half of 2, which is 1, so that's up 7. And then instead of going up over 4, excuse me, we're going over 4 times 3.5. And that's 12 plus 2, or 14. Now, our answer is not 7/14. It's saying we go up 7 and over 14 from this point 1, 4. So I'm going to keep track of that on the side for a second. So Q is at 1, 4. And our image P prime, we're going to go up 7. So be careful, put that in your Y position and over 14. So 1 plus 14 is 15, and 7 plus 4 is 11, which is where our image is. Now, you can see that's kind of where it is, right? 15 here, and then 11 on the height. It's a nice algorithm. You just got to really pay attention to the space that you're working in, and that's one way to do it. Another way to do it without using the slope, or if the slope's not a friendly choice for the problem you've got, you can think about translations. So the idea, let me go back to show you what I mean here, is, I think, what's the best way to do this? I'll just start over. No, I think I got this. So I'll say segment, I'll do a segment from P to Q. All right. So imagine the original point we're dilating from Q and P are onto this segment. And instead of dilating about Q, which is not at the origin, the idea is to take Q, translate it to the origin, bring P along the same translation, and then dilate about the origin, and then translate back. So it's translating, dilating, translating back. And that sounds like a lot, but let's look at it visually for a second. So this is hard to think about. The idea is, okay, take Q. I want it to go by ones. I don't like this going up by twos. There it goes. So I take Q and I bring it left by 1, and then down by 4, and I bring P the same amount, left 1, down 4. I dilate P where it is right now about the origin. It's going to give me this image up here, but that's not my answer. I've then got to go back. I've got to go over 1 and up 4 to where Q began, right? And I hope it's snapping to the point. There it goes there. So that's the algorithm. Bring it over, down, reflect it across the origin, or dilate across the origin, excuse me, and then bring it back up and over and bring the image with it. Okay, so let's do that. So first, okay, go over here. I think the difficult thing is the notation. So I'm going to show you what works for me. I start off with this point P, which is at -3, 2. And I want to translate it by whatever the opposite of the Q values are. So Q is at 1, 4. I want to bring it left 1 and down 4. So I'm going to go left 1 and down 4, because I got to bring P with it. And I call this point the translated P value. So if I go left 1, it's going to give me -4 from -3. And I go down 4 from 2, that gets me -2. And I don't need these brackets here. I want curly brackets. I was using the harsh brackets for the translations, sliding around, but not for the point itself. So -4 and then -2. Now I take that and I dilate it about the origin by whatever the scale factor is, in this case -3.5. Now remember, a dilation of my translated image, that's what this means. I'm dilating this point. About the origin, just take -3.5 and multiply it by these 2 points. That's why this is so nice. So -4 times -3.5 is positive 14. And then -2 times -3.5 is positive 7. But that's not our final answer. We've got to translate back, and it's always going to be the opposite of whatever this is right here. So it's the opposite of it. So we're going to do a translation of +1 +4. And that's going to get us the image of the original point. So +1 on the x is 15, +4 on the y is going to be 7 + 4, or 11. That's the second algorithm. I like that one. Another one you can do is to take all of these ideas and put it into algebraic expressions and thinking. So let's say K is your dilation factor. We're always taking the x value of the original point, and I'm trying to talk about this algorithm right here specifically. We take it and we subtract whatever the x value is of the center of dilation. I'll call that A. In our case, it was subtracting 1, the x value of Q. And then we add it back after we dilate it. For the y value, it's the same thing. Take the y value of the point, subtract the y value of the center of dilation, dilate it, and then add it back. So let's try that out here. I'll give myself some more room. The k value is negative 3.5. The original x value of p is negative 3. And we subtract the x value of q. And then we're going to have to add it back after we dilate. And then we do the same thing for y. So negative 3.5 times the y value of p. I jumped around there, sorry. That's interesting. I don't know why I just pressed. So, sorry about that. 2 minus the y value of q, which is 4. Dilate it and then add it back. So let's follow our order of operations. Here, the first thing you want to do is work in your parentheses. Negative 3 minus 1 is negative 4. And then you have negative 3.5 times negative 4, and then you're going to add 1. And for the y value over here, you do 2 minus 4. That gets you negative 2. Next thing we do is we dilate or multiply here. So we're going to do negative 3.5 times negative 4, which is positive 14. And then we're going to add 1, which is 15, the x value of the image we're looking for. And then over here we do negative 3.5 times negative 2, which is positive 7, plus 4, which gets us 11. And that gets us the point 15, 11. So that's a nice algorithm too. It shows you the kind of the translation process here, but in an algebraic structure. All right, so the answer is 15, 11. Let's go back, and I think I have that right here. Let's just write that down. So my answer for the image of P is 15, 11. All right, hope that helped.